Okay, YouTube Nation, sorry for my very crude notes today, but we just want to do a very basic introduction to polar coordinates. And there's a couple different ways which we can represent coordinates. You guys are used to what we refer to as rectangular coordinates. And we also have what we call polar. Rectangular coordinates have the normal form of x and y. And we will plot them. So for example, if I had a coordinate right here, I would plot that in accordance with an x value and a y value that we connect with an x-axis and a y-axis. You guys obviously know this, 4 quadrants, positive, negative. There's also a way to do it with polar coordinates. And this is just an abstract example. Polar coordinates require that we know the distance from the origin to the point. And we give that a value. Anybody know what variable we use to express that? R. D is a good guess. But so polar coordinates start with R. What do you think R stands for? Radius. And once we know the radius, how far it is, the only other piece we need to know is the direction. And so we use theta to represent the direction. So instead of x, y, we can use r theta. This looks familiar to you because this is what we did when we were using vectors. Now, there's a relationship between these. There's a relationship between these pieces. Namely, if you want to convert rectangular to polar, there's a relationship that we look to exist between x, y, r, and theta. Can anybody guess what the relationship is between x, y, and r? There's a formula that connects them. Very good. This is an x value, this is a y value, and you can see that you know r squared is equal to x squared plus y squared. There are a number of different trick functions that we can use to solve for theta, but if we're given x and y, which of the three, sine, cosine, or tangent? We use tangent, and you guys remember this. Tangent of theta is equal to y divided by x. So those are the two pieces that we need in order to convert from rectangular to polar. Now, if we want to do the other way, if we would like to go from polar to rectangular, then we need to express a different relationship. And namely, x is going to be equal to something, and y is going to be equal to something. Well, let's look at the x value right away. If we're given a polar coordinate, that involves r and theta, and we're trying to solve for x. So we're looking at this portion right here. This portion right here, I'll circle in green. Tell me which trig function has to do with those three pieces. Cosine. Namely that the cosine of theta is equal to x value divided by the r value. So I can represent this by saying cosine of theta is equal to x divided by r. And if you were to solve for x, what would you do to both sides? Times by r. So namely, x is equal to r times the cosine of theta. Anybody want to guess what y is going to be? r sine of theta. So once again, you can see that trigonometry has many applications, various forms. Conic sections are important because we can actually, true or false, if you graph a conic section, it is a function. False, it does not pass the vertical line test. We can use polar coordinates, parametric equations, things of that nature to graph these. And so that's why they're of interest, because right now if you went to your calculator, you wouldn't know how to do it. But with the knowledge of polar coordinates and parametric equations, we're going to be able to do a good job with being able to graph some of these conic sections and other pieces. So I just want to try 2 examples, and you guys can have time to work. I want to teach you a very basic skill today, which is this, and then move on. So we'll do much more work on Monday. So let's look at this piece. Example 1. It says, convert 4, 2 pi over 3 to rectangular coordinates. Now, the first thing I'd like to do is, I think it's always important anytime you're converting back and forth to have a little bit of an idea or knowledge about where this coordinate is sitting. So if we have a coordinate like 4, 2 pi over 3, anybody know which quadrant that sits in? Oh. Yeah, but sometimes it's easier to think about theta first. Theta is 2 pi over 3. Anybody know what that's equal to in degrees? 120. So 4 2 pi over 3 sits right over here, and it goes out a length of 4 units, say something like that. So you can see that that's how we get to that coordinate. We want to convert that to rectangular coordinates. When we convert that to rectangular coordinates, will the x value be positive or negative? Negative. Will the y value be positive or negative? Positive. So if I want to convert this to rectangular coordinates, I need to use this. I need to solve for an x, which is equal to r times the cosine of theta, and I need to use y, which is equal to r times the sine of theta. Yes. Well, it's a guesstimation. I put it about 4 units away from the center. So I have this, circle here that I'm thinking about that's 4 units away. If I would have gone 4 units left and 4 units up, I would have ended up over here. So I went about 4 units away from the center. That's something you kind of got to make a judgment on, because it's not located over there. Can I answer your question after we do this? Because I don't think you guys will see it. Because we are actually we're going to come up with the over x and up y values right now. That's what we're going to do. So we need to do r times the cosine of theta. R is equal to 4 times, does anybody know what the cosine of 2 pi over 3 is? Do you have your unit circle sheet from the beginning of the semester? Have you memorized these values? Because the cosine of 2 pi over 3, hopefully you know it, it should be negative 1/2. So you can see that the x value comes out to be negative 2. Do people need an extra sheet? I could go make copies after this, but this sheet may come in helpful. May be helpful, may be useful. How about that? Come in handy. There we go. All right. So the second one I do, y is equal to r times the sine of theta. So I have 4, and I multiply it by the sine of theta. What is the sine of 2 pi over 3, or 120 degrees? Square root of 3 over 2. And when I multiply that, that reduces to simply 2 square roots of 3. So you can see that this has a coordinate of negative 2 and 2 square roots of 3. And so, to answer your question, Taylor and Jalen, you don't know how far to go over and how far to go up until you convert it to rectangular coordinates. So I made a judgment approximately how far to put it based on just my knowledge that it had a radius of 4. So I kind of had this dotted circle in my mind as I was picking out that point. Yeah, you sure can. You don't have to draw the picture. I just did that because I think it's important that you look at your point in the end. As you look at where I drew that, does that look like it about fits 2 and negative 2 and 2 square root of 3? I would say so. You know, you can multiply out 2 square root of 3, you get like 3.4. You know, it looks like I'm reasonable in my picture plotting here. So let's try our second one. You guys can start your assignment after that. Example 2 says find the polar coordinates of 3, negative 3. Now, once you get good at this, you know, for example, I happen to be good at it. I could look at this like when I was doing first out or second hour, I knew it right away. So some of you guys will get good at it, you'll see it right away and you don't have to go through all the work. I'm going to show you all the work, but you should see some, geometrical connections here, pieces that you remember for geometry and, the beginning of trigonometry and everything else that can help you just identify these pieces. But so 1, 2, 3, 1, 2, 3. So if I plot 3, negative 3, anybody know what kind of triangle is formed by plotting that? 45, 45, 90 triangle. So, I mean, as soon as you see that, you can start to think to yourself all the different pieces that you need to figure out. But we'll do them by hand. In order to figure out polar coordinates, I need to do first r squared is equal to x squared plus y squared. Okay? Because I have to come up with, I want to take this and I want to convert it to an r theta value. And so I need to come up with r. So I use r squared is equal to x squared plus y squared. What's x squared? What's y squared? So that means that r is equal to, r is equal to the square root of 18, which is 3 square roots of 2. Well, that should probably make sense to you. If you have a 45, 45, 90 triangle, you remember that this length is, the legs times the square root of 2. So 3 square roots of 2. Maybe you already knew that. Good job. If you didn't know that, you would have to figure it out by means of that. In order to figure out theta, what do I use? Tangent of theta is equal to y divided by x. Or in this case, tangent of theta is equal to negative 3 divided by 3. Tangent of theta is negative 3 divided by 3, or negative 1. Now, the negative is important to identify which quadrant I'm in. Tangent is negative in the second quadrant and the fourth. Which one am I working in? The fourth. So we don't even need to use really the negative from this point, okay? 1 second, let me pause this. Okay, let's get back to this. Okay, so tangent theta is equal to negative 1. So we said I'm working in the fourth quadrant. When you type it into your calculator and you do tangent inverse of 1, you get 45 degrees. And so as you make your little picture, you're in the fourth quadrant, 45 degrees. As you subtract that from 360, you get 315 degrees, which is the same thing as 7 pi over 4. So there we've solved for theta. So our coordinate is r is 3 square roots of 2, and theta is 7 pi over 4. And that's how you solve for it. It could be 180. Could be 180 minus, 180 plus. It depends on if you're working in the first, second, third, or fourth quadrant. Well, because we found that tangent of theta is equal to negative 3 over 3. Right? When we got this, Levi, it says, so we had to solve for theta. In order to solve for theta, we do tangent inverse. The negative sign tells me which quadrant I'm in. If you want to take tangent and negative 1, tangent inverse and negative 1, you could do that too. That's fine. That's fine. You can do that. I've just always told you guys to keep it simple. Let's just use the negative to tell which quadrant we're in. and then just type in the positive number. That gives you a reference angle. Because some people, they get negative 45. They don't know what to do with it then. They're like, well, I got negative 45. What do I do? Well, just, you got to think it through. You got to be smarter than the calculator. So, okay. Any other questions? One once, twice, thrice. You are going to convert polar coordinates and rectangular coordinates, page 782, numbers 7 through 18. There you go.